Hello.
Again, sorry, I was finding my headset. I couldn't find it. Can you hear me?
Yeah, I can hear you.
Okay, wait just a minute. All right, and I see Austin. So great, Austin, can you hear me?
Yeah.
Okay, cool. Okay, that's very loud, which is good. Okay, YanKeen, please give me some updates.
Okay, so I went through the Chem Hydroxy tutorial.
Yeah.
And that's fun. I did start on the carbon, but not as much as I wanted to.
The tutorial, the carbonyl. Yeah, don't need to be a lot, right? Don't need to be a lot.
Yeah, the lecture as well is like there are only 2 lectures, but I'm only on lecture 1, so it's like
The carbonyl. You are already only on the lecture of carbon. Okay, understand. Okay, then.
Then physics. I think I made it to double slit. I wanted to finish the diffraction.
Double
yeah.
Okay, right. Okay.
And then math, I'm just working on presentation.
Right. Okay.
So that's about it. And
okay.
Yeah, some questions for.
Then I will like to help you with your questions. With the Jamboard, same thing with you, Austin. Okay, so Austin, last time we met, I believe there's nothing to catch up, right? So yeah. So give me some updates. What's going on?
My physics I'm at what is it called? Yeah, I forgot the name. Electric field.
You
Then
are at
for-
electric field.
Yeah.
That feels very weird. Why are you at electric? Oh, you okay? I think I will find out from your questions. Okay, then and
Then my chemistry I'm at carbonyl.
carbon.
Yeah, should be carbonyl. Then
Course, right.
math I'm at APGP.
AP. Oh well, that's surprising. Oh, okay, sure. I mean, APGP is important. Is the chemistry tuition taking care of the OChem stuff?
Yeah.
Okay, all right. Okay. Then good to have questions. Please ask me today. Turn your video on and the Jamboard, please. Okay, I can see YanKeen's video.
Let me add the picture.
Sure.
Can a lot of the Chem one is like structure elucidation. So yeah.
A lot of Chem 1 is what? Sorry.
Structure elucidation.
All right,
Yeah.
sure thing. Okay, yeah, nice. Zoom out a bit, just a bit, just a bit, just a bit. Zoom up just a bit. Yeah, okay, nice. Okay, do you have the
It's
gem?
10 and 11. 11 is on second page.
Sure. Again, Jamboard, please. Okay, YanKeen.
I'll send
I
you
got
now.
YanKeen. I got it. Okay. Got Yan. Hey, wait. Oh no,
I'll send it to
that's
you now.
not right. Okay, that's not. Yeah. Okay. Okay, Austin, I can see your video. Okay, then I'm gonna copy. YanKeen. Sure. Okay. So let's talk about 10 first, I suppose. Let me read. I can copy the 11 now.
No, 11 is.
Yeah, there you go. Okay, got it.
Yeah,
done. No, done. Both are done.
Sure.
Okay, let's talk
11
about.
is like A and B.
Yeah. So 10 first, I suppose. Then, type of. Okay, then yeah. Okay. Yeah, sure. Okay. Yeah lah. So this is playing detective lah. So he's telling you a lot of things about the thing, and then we just. I mean, this is just a more advanced QA lah. I mean, referring to.
Yeah, I know.
Right? Okay. So MNPQ, right? That's question 10.
I did try. I did get some like conclusion.
Cool. Okay, let me check first. Oh wow. Okay. Right. Okay. Yeah. Produces with fumes. Produces.
I read
fumes.
the
white fumes.
Yeah.
You mean white fumes? Sorry. Because you write with fumes. Okay. White fumes. Okay. Sure. So the M. But before we even go to this, right? There's the first sentence: decolorizes aqueous bromine. That is a very classic, very classic observation that tells you something. Do you know what that is? Because I don't see
that one
it
is
here.
which one is it called? It was the reverse, right, of the state equal phase substitution and all that.
Okay, I'll say it very clearly. This is just an indication of double bond.
Double bond. Oh, okay.
Yeah. So you go to alkene quickly. You go to alkene. Okay. This one is classic. That means I really want you to have that impression. Go to alkene. The first few reactions. The one with aqueous bromine. Yeah. Just look at it. Right. Alkenes. Double bonds. Yeah. Double bonds. Yeah. Hydrogen halides, yeah. I mean, just okay. This is Br2 in this medium, whatever. Decolorization of orange Br2, right?
Okay.
Like in the Br2 is obviously absorbed in, right? Basically, right? Okay. So okay, so that means M as a double bond, and it's not surprising because the content of H is like so much less than C, right? Okay.
And like it reacts with the acidified KMO4 as well. So
the reacts with as well.
the hot acidified. So
the M.
Like later on, it reacts with
Yeah,
KMO4.
because acidic K. Yeah, the acidified K2Cr2O7 means yeah, tertiary lah, because because that's a medium kind of oxidation, and then the strong oxidation will give you, well, NPQ lah, right? Okay, then your N effervescence, P effervescence, sure. Oh, it's just all of them
me following what the
right.
Just me following what the question gave me.
Yeah. So NP and Q seems to be acid lah, basically, right? Just basically acid. So I mean, there's only one acid that we know strong enough so far, so that's great. Right. Okay. Right. I noticed that the N, they give you the formula. Okay, great. Yeah, I like it. And can you read for me the formula of P? The formula of P. I cannot read it.
P4605.
P4, 6. Oh, P4, 6, and 5, right? 4, 6, and 5. Right?
Yeah.
So this is a 5. So let's stick with the 2 first. Okay, I'm just gonna aim for the easier guys, and I think NP and Q are easier than M, because M is like the big guy, right? Should be right. And then N is a small. In fact, Q I think is very easy. The O2 is already a good indication of carboxylics. So the N and the Q is almost certainly carboxylic acids. And I think you can already draw Q, I feel. Use pencil, please. Like we have to play around, right? Even in exam, you should. So try Q first. Right, okay, that's C. And is this, C2H4 O2 lah?
Oh, it is.
It is, right? So Q is done, right? I don't think Q you need to worry so much. As for the N, I cannot read the H. How many H is that?
M or N?
N first.
C7H6O2.
C7H6O2, right? There's 7C, there's 6 H's. Yeah. Okay. So with this kind of like look at the ratio of H. It's just so little, right? There's so little H. I mean, we are usually tempted to try cyclical stuff first. Let me think.
Yeah.
And with with a COOH branch, side branch, maybe we'll try that. You probably shouldn't be erasing Q, because actually they ask you for the Q. Basically, they ask you for the structural formula. So like drawing structural formula of Q is basically you're answering the question, right? So it's a Q. Right? So try N, try cyclical, simply because the H is small and with the side chain. Give it a try and see what happens first. Or a benzene ring. Just try a benzene ring first. Just try a benzene ring. Okay, give it a try. In the meantime, I'll try to understand Austin's question. Austin, yeah, we have a long question here with YanKeen, so don't wait for me. But I want to understand what questions you have first.
Oh yeah.
YanKeen, count the H and see the discrepancies, right?
C6H5 and COOH. I thought, okay.
Count the H in
1, 2, 3, 4, 5, 6.
That is APGP. Good. So you're lacking something, right? So I suppose we give it a try. Think about it, and then for P, try some sort of a double carboxylic first, like both ends, and think about because then you get 4O, and think about one more O coming from where. So I'll give you some ideas based on that first. Right. Okay. So Austin, right? Okay. Yeah. So question 1, is it, Austin? Sorry.
Yeah.
Let me see. Yeah. Okay, nice. Right. Okay. So you want to find. Okay, great. So he tells you. Let me think. Right. So he doesn't tell you whether this AP or GP. There are other possibilities, but we'll stick with them both. So how do you know that this is either AP or GP? Any way to know? Never mind, I suppose. Right. So I'll ask you to compare with a formula, right? There's a formula for APSN and GPSN. So do the comparison first.
I thought it's AP.
Correct. Then give me the formal formula of APSN, and then we'll do a comparison. You need it anyway. You need it.
I think I wrote it here.
Right next to this SN, this nice SN, please do. So YanKeen, if I'm not mistaken, the N has problem with H, right? Because currently it's H7, am I correct?
Oh, H6.
Oh, it's already H6. You found N
Yeah.
already. Oh, N is that?
Yeah.
Oh, N is that good. Now?
Oh, it was much easier with stop benzene. I thought it was 7, then it was a weird cyclical, so I didn't.
Right. So if you're certain, good. I mean, it shouldn't be that big of a problem. Now, P, I need you to draw, double-ended carboxylic. I'm not seeing anything. And even if it is a mistake, don't erase it first. So double-ended carboxylic. So 4 C's, right? Right. Okay. Then we'll start from there. Okay, good. Now, Austin. Yeah, because I see a lot of O. Like one N is already 2 O. So 2 N's are 4 O's. So let's count the H and the thing first and see what happens. Then we'll solve the other O problem, right? So Austin, at this point, you know the N over 2, like it's a very suspicious thing, good. So then you should probably know. Okay, so you're going to expand the guy inside the formal thing. You're not going to do this kind of comparison. You're going to expand the guy inside the bracket, the formal guy, the 2A plus N minus 1B. Expand that, please. Especially the N minus 2. Okay, nice. Okay, sure. Minus D lah. Okay, maybe you do a bit of grouping, and I think this is a better comparison, I think, than what you're doing. I think.
So,
yeah. There's only one N, for example, right? There's only one N.
so I think.
So you do the comparison properly first, or rather, this is an alternative comparison. Good. Yeah. Getting somewhere. Yeah. So YanKeen, what's the current number? Like how many C and O and H are we having here?
I'm missing one O, but the C and H.
The H is correct. Yeah.
So 1, 2, 3, 4, 5, 6.
So my direct guess is an OH lah. My direct guess. I might be wrong, but that's the simplest way to solve the problem.
But where would the OH be? Like,
I am not sure,
like
but I don't think it matters. All of them will become like they're similar because they're symmetrical. If wherever you put it, don't you think?
Oh.
Right. So happens because it's symmetrical lah. So happens lah. So I don't think it matters lah. Okay. Understand? So you put one OH first. I'm not saying that is correct, but I'm saying that that's the easiest way, and then you should confirm it with what they're giving you lah. Try to check first, because like what is this like no color change observed on heating it. What's that? How does that fit in with your, I don't know, your alcohol thing lah, I suppose.
No color change, meaning
on heating it with acidify. If you don't know what's the color change, right? You go to
Isn't that the indicator of the sharing? I mean, it doesn't. Or
you can check the note.
Or does it mean it does not react, or does it mean it reacts but there's no color change? Because I don't know if those are the same thing.
Let me think for a while.
Sorry. Oh, nah.
Because this is acidic, right? This is acidic. Oh, wait. Oh, this is okay. The acidic end, we established that the acidic end is the peak of oxidation. You cannot oxidize further without actually burning it. Makes sense, huh? Correct? But you can oxidize the alcohol. The alcohol is open for oxidation. I mean, there are some possibilities of oxidating the alcohol. I think that's what they are trying to do with the acidified K2Cr2O7. So whether that happens or not, you have to focus on the alcohol, I believe. And the no color change observed, you should think about what that means. Whether the alcohol reacts or not, you should think about it based on this structure. I will actually expect, since you, for example, you know that the tertiary alcohol don't react, so you already know some limitations of the K2CR2O7, right? You should already know that.
Oh, you mean for P?
For P, yeah, P, because N and Q, I mean, P is the only thing we have with additional information, right? So might as well just confirm that first, right? You should, right?
No color change.
So you read the note, just clearly read the note and interpret properly. So Austin, are you okay? Are you done? Sorry, because you found the D and the C, or you're done. Okay. So I think this is a good experience. Second question. What's your second question, sir? Second question is?
Question 5.
I need to see the question. Okay, that's nice. Might as well just copy first. Looks long. It's very blurry, Yeah, but it's good enough, right? So he tells you it's AP. That's nice, right? Tells you it's AP. Do I have your Jamboard? Yes, I have it.
It should be.
So is the alcohol reacting or not, right? I will be with Austin for a while, so think about it for a while, and then try to construct the original guy already. I mean, we can already play around. We can already do that. Yeah. Nice. Okay. Okay, right. Okay, nice, very nice. Okay, so what did you do? Show me what you do, Austin. S100, yeah, I agree with you. So let's agree with that first. S100 equals to T, and S100 is that thing, right? Very nice. Okay, very good. Then what we want to talk about is probably this. So before I talk about it, so you don't have A, you don't have D. Okay, I'm going to talk about this guy, right? So I'm not sure whether there are another way of doing it, but I'll do it one way, I suppose. So the sum of the, okay. So basically, for example, I have A, right? Then I have A plus D, and then I have A plus 2D. That's my third term, correct?
Yeah.
And then dot, skip. And then I have obviously A plus 4D. I can predict that already, correct? Correct?
Yeah.
So if I were to ignore this, just to be clear, this skip is are you seeing 2D. The gem? Yeah, plus 2D. So let's say I don't understand your working. Did you actually realize this? This is what we can tell from the 50 odd number terms.
I mean, I wrote 13579.
13579. Oh, yeah, sure. I'll write this way. Look. I have a first term, right? So I have A, right? Oh, sorry. I have N over 2, right? 2A plus N minus 1, the common difference, right? Correct? However, in this case, this will be 2D. I'll view it that way.
Yeah.
Right? And just to be clear, I will no longer view this as third. I'll just view it as first and then second. I mean, I can do that, right? I can do that. It qualifies. First, second, third. I can do that. Can you accept that?
Yeah.
So this blue guy, I'll say S50 because there'll be 50 terms. So 50 and this is 50. And the starting guy is still A, so I'm okay. Right?
Yeah.
So I have this T equals to that thing that you wrote, and this is now equal to half big T minus 1000. Now, in your working, have you tried doing this guy?
Which one?
This guy.
Yeah, I tried. But I think I got this part wrong. I got the common difference wrong. I would 2 instead of 2D.
Yep, I think that will be 2D instead. Correct. I think that will give you an idea. Good. Good. And then we'll probably have to do a comparison or just sub in the T lah. I would, if I'm lazy, I'll probably sub in the T look. I'll probably just sub in the T from above lah. Probably lah. Yeah. Okay, give it a try. Give it a try. That makes some sense. Yeah. That actually makes some sense, right?
Because I try to come up with this, right? But I can't, in both these situations, I don't know why I can put the OH in a position where it will be a tertiary alcohol. Because if I put here,
right.
If I put here, there's one H, then it's a secondary. If I put it anywhere else, it will still be a secondary.
Correct. So that's our problem, right? No color change is observed in M. You have the double bond, so that's done. It's C4H6, so it doesn't give you much room. It has to be tertiary then. Okay, fine. If it has to be tertiary, if it has to be lah, so here I'll give you the alternative key lah. So COOH, right? COOH, right? Then like this C and and then you can put the OH here. Would that suffice?
Are you drawing in the Jamboard?
Yeah, I'm drawing in the Jamboard.
I can give it a sec. I'm still loading.
Right. Austin, are you okay? Sorry. That's
Yeah, I'm taking eraser.
Oh.
Oh.
Yeah, that might work lah. If we have to make it tertiary, that works, I suppose. Right. If that's the only problem, then solve problem lah. Problem solved.
Then I will just move this C down here.
Yeah.
For the big N.
Yeah.
Okay.
Now, it's a detective work, and I think you're in a position to enjoy this kind of thing. I feel like you have enough knowledge and enough taking some creativity with the structure. I don't think you have a problem with it at all, especially when you start drawing. If you don't draw, then I don't think you can do it. Right? Okay. Yeah. So expect this kind of thing in exam. Obviously, it's an exam question, and I feel that there's a good chance that you will enjoy this. Right? So hopefully that's the case. Now finish it up and reading question 11. I'll just move to the next page. I think that's better.
Right. Oh, there's also one more, but I'm not sure if it's a question or not. Let me.
Sorry, just a minute. Sorry, you're saying one more as in question 11 or what?
Oh, no. There's one more question after 11, but I'm not sure if it's not really a big question.
But let's do 11.
No? Okay, yeah.
Right, let's do 11. No problem. Are you saying that 11 is currently also a blank? Compound L. I cannot even read L. L and M is what? C9, is it?
C9. Yeah, C9H10.
Right. Again, owing to the nature of the C and the H, I immediately suspect that it's some sort of cyclical stuff or benzene ring. I will immediately suspect that. that's something that I feel that you should do also. Like for example, that's how we suspected N, right? Hiyo, so small of a ratio, right? And they even tell us that P has a benzene ring. So I think that that's already kind of like it's a good thing to try, right? And compound N, so everybody gives this. That's what he's saying, is it? Everybody is giving us this.
Yeah.
Right. I'm not sure about
this.
this.
That threw me off. I don't know.
Right. So this is C8, right? So P is C8, right? P is C8, right? C8. I'll say O4, and the H is how many?
H is
calculate the H.
C6 plus 2.
No, it's not 6. It's not 6. Come on, it's not 6. It's not 6 plus 2. It's not. I mean, this guy and this guy take out H, right?
Oh, so it's 6 minus 2.
Plus 2 lah. 6 minus 2 plus 2, right?
4 plus 2.
Right. 6, so 6 lah. Right. So I mean, writing this is already, I think, useful, right? I think you should write down, and then you have some sense of things, I suppose. Right.
Okay.
So I'm not sure what happened to the 1C. Benzene 1,2 dicarboxylate. Yeah, I'm not sure currently what's happening to the 1C, but I feel that that's probably what we want to think about. Yeah, definitely that's what you want to think about.
Carbon to carbon dioxide. That was my first thought.
So what allows, how does that, yeah, so what kind of N, what kind of side chain or N, right? What kind of side chain or N will make it so, right? It will make it so. Hey, sorry, Austin, sorry. Done, is it? Sorry.
Yeah.
Oh, done. Sure. Okay, so just missing that. So excellent, what you're doing. Just missing that. What is the next question? So YanKeen, you think about how to lose 1C here, right? Think about that.
I think I'll do like one more question.
Sure. Yeah, can I see the question first so that I can follow you? Question 7, right? APGP. Yeah, very important. You're only a tutorial, the first tutorial of APGP. Am I correct?
Yeah.
This is the first. Right. So I'm hoping that your tutorial will not yet. Doesn't seem so. Okay, very laggy. No, very blurry. I'll try to copy. Steady. Nice. Yeah, a bit blurry today. Okay, I'll try to follow you, Austin. How is it, YanKeen? Is it possible to lose 1C here?
I mean, one of them will have to be like something like this, like carbonic acid,
right? Carbonic acid.
So it will decompose into carbon dioxide, water, and they will just. But they oxidize it, right? So that means there's oxidative cleavage.
Wait a minute. Wait. What? The criteria for it to change to CO2 is, I kind of forget. The criteria is that they are both, they are terminal C's, is it?
Sorry?
They are terminal C's, are they?
I thought it was to turn into CO2 and H2O, it must be like the structure, then it will break apart, and then after that.
You mean this is the only structure possible?
Right, once you do the oxidative cleavage, then you get that.
I can. You can. What? Wait, I don't get it. What? Am I forgetting something? Wait, what? Wait, sorry. Let me think. Yeah. I'm going to start with the L first, right? Okay, well, while reading, again, I noticed that L reacts with Br2, and that's again classic. That's telling us something, right? What is it? I lost your video, Austin. Yeah? Again, YanKeen, you're not reacting to Br2 aqueous. Like no. Again, Br2 aqueous.
I mean that's alkene, right? It's a
right. And I suppose the alkene is not in the benzene ring lah, but on the side change lah, I think. So we can at least try that. We can at least try a side chain with a double bond, right? At least, right? Okay, double C, and then there's no other O, right? There's no O allowed, so there's only H's lah, right? So one H over there and two H over here, right? H, and then the other one, right? So we are left with one more side chain. We don't know where that is, so we just randomly assign in position 3 or 4 because that's the only possibility anymore. Either position 3 or position 4. We don't know where, right? Let's just hang on there. We can probably get. Oh wait, sorry. From the resulting P is probably at position. I'm so sorry. It's probably at position 2. Probably lah. Judging from P lah. Probably. Probably, yeah. Probably, I'm guessing. And then this will be a C and then no other thing. So again, count the H's first. Count the H's.
So this is 6H, 7, 8, 9. That's 9. Then the H is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess that satisfies.
Nicely, yeah. So we are unlikely to be wrong based on the clue from L, right? Based on the clue from L. So yeah, so the terminal C lah. So what I mean, the terminal C beside a double bond, right? The terminal C beside a double bond will detach into a CO2 lah, basically, right? Basically, no. That C will detach into a CO2. That's the requirement there lah. So because I'm very confused with your C double bond to O. That's not what the note meant. I think it's no. Probably means more like a C double bond with C, I'm guessing, not C double bond.
This is like what happens after the X oxidative cleavage, you know, like break apart, then there's an O here instead.
I agree. Yeah, that's what happened after. So okay, yeah, great. Okay, if that's the case, I agree. Then this guy will be a good candidate to break apart, right? This is our L, right? So how can M break apart without an alkene bond, right? Without a double bond? Is there any other way to break apart? Is there another way? Without O somewhere, right? Because you cannot double bond there. You cannot double bond a benzene. You cannot double.
No, I don't think you can.
No, you cannot. The pi bond doesn't allow.
Yeah.
The pi bond doesn't allow. Whatever, man. Let's try N first, right? Let's try N first.
Okay.
So you have one O. There isn't much option, right? One O means either ketone, aldehyde, or alcohol, right? That's one O lah, right? So let's give it a try. Let's give it a try. Right? Give it a try. Austin, are you stuck? Sorry.
Sure. Okay, I don't understand what it means.
Right. Okay. So let's talk about the question, right? So yeah, starting to be weird stuff, right? Let me clarify a few things in the Jamboard. This is UI, is it?
Yeah.
UI, right? So that's not very helpful, right? UI, PI. Am I correct?
Oh, UI is equal to P.
Oh, comma. Okay, there's a comma, right? Where P is a constant, and this is UN plus 1, right? Okay. And let me confirm that this is UI, not U1 lah. It's not U1.
It's I.
Okay, so right. So and then UN is 2. Oh wow.
2UN minus 5.
Yeah, that's wow. Okay, fine. Describe how the sequence behaves when. What does this mean?
Yeah, exactly. I don't understand also.
Oh, when when option A, that's not, this is option B. Like question 7A, part 1, part A of part 1.
Oh.
Yeah, so he's just saying this low, that's so annoying, right? But that's just what he's saying. He's saying that P is 7 now, right?
Actually, how does the sequence behave? I don't understand.
So back to that first. Are you sure this is UI, not U1? Can I just confirm that?
Yeah, it's UI.
I don't
Okay,
understand.
I can show again.
Can please.
I changed
don't
my
understand
network.
what. Much better. Thank you. I don't get what you. Oh my goodness, that is UI. I don't get what UI means.
I think it's a first term initial or something.
There is no proper language for UI. What are we talking about here? You're supposed to say UN, or you. Huh? Look, I'm gonna assume that this is U1 because UI doesn't seem to be a proper map language, right? I'm gonna assume first and see what happens. UI is P lah. So in this case, 7, right? Okay, so let's say I pretend that UI is 7, right? This is a 1A, right? 1A, right? Okay, then U2, I'll just use the formula, right? So what is U2? U2 is 2 times U1 minus 5, right? 2 times 7 minus 5, which is 9, right? Am I correct? Right, yeah, 9. And then U3 is equal to 2 times
7.
No.
2 times 9.
Yeah, minus 5, which is
13.
Right. So let's see what happened, because I think we do one more just to see what happened, right? So
2 times 13 minus 5.
21, I believe, right?
Yeah, 21.
So let's see. Obviously, this is not AP and this is not GP. So this is plus 2. This is plus 4, and this is plus.
Plus 7. Plus 8.
That's so weird, right? That's weird. And then this is we are predicting this is plus 16.
This plus 2.
Right, plus 2, plus 4, plus 8, and then we are predicting this to be plus 16. I'm just looking at the pattern here. So let's see. U5 equals to 2 times 21 minus 5, which is
42 minus 5 is 38.
37, yeah, which is plus 16, right? So plus 16. So I'm not sure how to describe that, but at least we can predict how the sequence behaves. If you can predict how the sequence behaves, plus 2, plus 4, plus 8, plus 16, then we can describe it. I do know what this sequence is, though. This is a quadratic sequence. This is something that you learn in O-level, EMAP, rarely, however, rarely.
Oh.
Oh my goodness, no, this is a cubic equation. Oh my, it's a cubic equation. Let me check first. Plus 2, plus 4, plus 8, plus 16. No, it's not. This is plus 2 to the power 1, plus 2 to the power 2, plus 2 to the power 3, plus 2 to the power of 4. I'm not sure how this is, but this is how it works. This is how it works, right? Now, IB. Let's do the same. Again, please do the U1, U2, U3, U4 to see a pattern, and then let's see what happens. Please do that.
Okay, sorry, can you repeat again? I didn't catch it.
Again, for the P equals to 5, we just repeat the same thing to see what happens. Okay. Give it a try first. Right. So YanKeen, you have your.
I'm thinking it's an order height.
That takes care of the O, and then the other guy is.
The other guy would probably
is C2. Right? Yeah, but then you lose one.
I'm missing. Yeah, I'm missing.
So it has to be C2H5 lah. It has to be C2H5. That's one possibility, but if you do that,
no, because then it needs to be carboxylate right at the end.
Yeah, you cannot do anything with that. That thing cannot be oxidized. I mean, that's why we're trying. Can you move up a bit? Sorry, can you move up a bit? Yeah, that thing, right? Yeah, even right now, I'm thinking about how to oxidize the L, right? How to oxidize the CH3? Actually, is it even possible to oxidize?
I'm pretty sure pretty sure CH3 can be oxidized, right? Like in the benzene ring, it oxidized becomes COH. I don't know how it works, but I just know that it can.
Actually, I have no idea. Could you check that? Could you please check that?
Yeah, let me check my team.
Could you please check? Yeah, because I'm forgetting things. I'm forgetting things. So U1 is 5. Just still assuming that U1 is 5. Then U2 is 5. Right.
Yeah,
Okay. Yeah. And therefore U3, U4, U5 is all 5 lah.
Oxidation of the side chain alkyl.
Oh, we can. Oh, I didn't know that.
Yeah.
Because alkanes or benzenes are supposed to be inert, but I'm sorry, I do not know this. This is a very strong oxidation. Wow, that's super strong. That's super strong. Okay, right. Thanks for correcting me. Now I know. So Austin, currently we are assuming that U1 is UI. I'm not 100% comfortable, but as you can tell, we can predict the thing after assuming that low. So we'll leave it like this first. I'm not sure whether this is 100% correct, right? Because I'm changing the question. Yeah? So I'm not sure where this goes. Find the value of P for which U5 is 101. Okay, let me clarify one thing, because there's a change in the syllabus in A level that I'm not sure of, right? So in your APGP, before your APGP, did you talk about something called a recurring function?
Huh?
In your notes, in your AMAT notes, did you talk about recurring function? Recurrent function?
Or inside my APGP notes?
I think before APGP, last time it was before APGP. Then I feel that somehow it was taken off, maybe because of COVID or something. I don't know.
Before APGP it was complex numbers.
It was complex number. You jump to AP. Okay. Like when we talk about MOD, there's the sigma thing. There's a sigma notation. MOD. Usually recurrent happens there. Recurrent function. That's like, I don't know when you learn sigma notation and
I haven't learned.
You have it? I don't get it. Okay, then never mind. Then let's not talk about something like that. Let's just talk like this. Okay, even if it is 2 marks, I don't know how else to do it, but to do this. So 101 will be 2 times U4 minus 4, 5, correct? So therefore, U4 will be 106 over 2, which is 8, sorry, which is 53. Look. That is what I'm going to do. Look. You know what I'm going to do? U4, sorry, and then 53, sorry, where is my drawing pad just died. Okay, you know what I mean? I'm going to trace back to U1. I'm going to trace back from U5 to U4, U4 to U3, U3 to U2. That's the worst thing that we can do, and it'll work. Oh yeah, my drawing pad just died.
I mean,
U4 is equal to 106.
No, that won't solve the problem.
Right. 101 equals to 2 just do simple algebra. And simple algebra is what we're dealing with here in the end. It's a weird topic, but it's like that one. The math is not fancy. The questions can be fancy, right? So I think I agree with you. Thank you for teaching me, YanKeen. So that's L, right? But
for M, like M for mouse, right? M, if I try to find another isomer,
yeah, because that's what we're doing. Yeah.
I was thinking of like that, and then C, and then after that C, and like that. But that will be 9. So
yeah, that's why. And you adding it, if you put a C2H5, you will give you a problem that cannot be solved, right? So we are avoiding C2H5, correct? So that's something that we know. I think we can only have 2 side chains, and then we cannot deal with C2H5. So I will do what? I will make them cyclical again. That doesn't make sense. The worst thing I can do is I can just combine the 2 side chains. right? So this is what I mean. So again, we know that we are limited to not C2H5 and we are limited to 2 side chains. So I'm going to do that and see what happened. Can you see what happened? Let's see how many H's can this, does this, is this oxidizable? I don't think so. Right? I have a problem imagining all this, right? I have a problem.
Really connecting them together?
Yeah, it doesn't solve anything, right? It doesn't solve anything. And we still need this to be oxidized. Okay, I have no idea. I currently have no idea, right? I have no idea what is M, but we can figure out N lah. I mean, are we done with N? Not yet, right? Not yet. So you have UI, right? You have UI. Austin, sorry, yeah. Just, Austin, you have UI, right? So I suppose we are done with the question.
Just wait, I can check the answer.
Oh, yes, please. Oh, you should tell
me.
Yeah,
it's 11. Yeah, so it is. Yeah.
So that means UI is U1 lah. That
Yeah.
means lah. Okay, great. We're happy. We're happy. We're happy. Now, the B, which is like V1, he gives you V1, right? Okay, great. V1 is A, V2 is B, and then he gives you VN2, VN, whatever lah. This whole thing lah. This whole weird thing, right? And for some reason, he gives you another thing. I mean, whatever, man. I'm just gonna use this, right? I'm just gonna use this. I mean, what else can we do, right? So we're just going to use all this lah. So observe, observe. This is probably V3 and this is probably V4, if that makes sense. And this is probably V2 lah, right? Okay. Does that make sense for now?
Wait, what?
Again, I can put this as V1. I can put this as V2, and therefore I can put this as V3. But it seems to want this. So okay, I'll shift. I'll do this V4, V3, and V2. That also makes sense, right? Whatever you want, right? Okay, then you know what? V4 can change to something, right? To V3, and then V2 can change to V, right? So I think we can solve it this way. I think. I'm just doing simple algebra and substitution.
Wait,
and
so V2 is equal to
B lah, because they tell me, right? They tell me.
Really? Where? Oh yeah.
What? Reading. Okay, reading. I know it's confusing to read.
So it's just substitution, right?
I am currently substituting. I haven't found B lah, but at least I found something nice, I suppose. I mean, I can probably find V3 right now. I can probably find V3 right now. Probably.
I'll try it out.
Maybe, yeah. Give it a try first. Let's see what happened. Yeah. So YanKeen, any progress on N? Nothing yet.
Like N or M?
Yeah, N.
Both are.
Yeah, I'm still not sure about M at all.
I can't put another O there, but
you can't. No, you can't. You cannot do C2. So let's say we stick with CH3, right? Let's stick with CH3, the other side. Let's just stick with CH3 on the other side, right? And that other guy, we extend the C by 2. Is it possible to salvage anything like that? The first side chain 2 C's lah. And then C. No, not the second one. The second one, if you do C2H5, you're stuck already.
Then yeah, but
No, maybe. The first side chain. Can the first side chain be, 2C somehow and still get oxidized? Is it possible?
I mean, it could, but then I couldn't put the C here because I got the O. I put the
no,
C
you
here.
Cannot. If you put the C there, what will happen?
I put the C or the H, then
yeah, what will happen? And then you put C and H. Just give it a try.
Then it won't happen. Wouldn't it? Then it would just be
yeah. Yeah. Again, the question is where would it oxidize? Where would it oxidize? That's the question. Then you have a CH3 there lah, standard lah, right? Does the H fit 6 plus 4? Yeah, 10. The H is still 10. So will this oxidize at the proper point and therefore cleaving away that C? That's the question you have to answer.
It's a single bond.
Where would this guy oxidize, right? That's the question. Where would this guy oxidize with the chem manifold? Where would this guy oxidize? Oh, you found it, Austin, right? Yeah, we're just substituting stuff and we found something.
Yeah.
Oh, the two V3 cancel. Oh, the two V3 cancel each other. Right. Okay. This is such a weird question, right? It won't happen again, right? But okay, we found something. Find a fraction of A in terms of A for sorry, is that V3 or V5? I'm sorry.
V5.
Okay, let's do V5 equals to V3 plus 2V4, lah, right? Just do what he gives us, lah, right? Does that actually make sense? Does that make sense? I have no idea. No.
I don't know.
He want in terms of A.
Yeah. And
We
V1
have-
is equal to A.
And we haven't found V3, right? We haven't found V3 anyway, right? So even if we say something like this, V5 equals to, V3 plus 2V4, right? Even if we do that, we still need the V3, right? We still need the V3. So let me do something else. So I just say V3 equals to V1 plus 2V2 minus 7. I can also do that, right? Let's do both and
What? V3.
V3 equals to V1 plus 2V2 because that's what they say. This thing, no? Same thing, like same thing. Right?
So
Correct. V1, V2, V3. Again, that's what they say. We just use it. Okay, YanKeen, have you any idea how that guy will oxidize? The first side chain.
Really? Because all the reactions I'm seeing here don't have. This is a ketone, right? And
That
the
is kind of a ketone. Yeah.
The reactions I'm reading from my notes don't show
How ketone will oxidize.
Yeah.
That's very weird. First of all, it is in carbonyl. This is still hydroxy. That's so weird. That's just so weird. I don't care. Let's go to carbonyl. By the way, Austin, your V1 is A, right? And V2 is. Oh, the V2 is 7 already. Yeah. So we have some A lah. Yeah, we have some A lah, right? We have V3 equals to A plus 7, right?
yeah.
Okay, great. And then now we use the V5 law because he wants V5. We use V5 law.
We need to find V4.
V4 is
by
2V3.
Okay.
2V3, right?
Okay,
So
I think
easy. Yeah. So simple algebra, but I feel it is weird. I feel like it's weird. So that's your feeling. As long as you can do it for now, it's fine. Yeah.
Oxidation only happens at aldehydes.
Because ketone cannot oxidize. My goodness.
Right? Yeah.
Okay, let's not do the colon one. Let's go to the summary. Let's go to the summary. Easier to look at the summary. Yeah, but at this point, you should be doing that, right? So not going to have reduction, not going to have condensation, not oxidation. We are these are not specific to aldehydes. Yeah. The alcohol also give positive tests. Right? So we are not going to do ketone. We're going to do alcohol. Simple, right?
Fair enough.
Right, let's do alcohol. So let's scratch ketone because we also cannot do aldehyde. If you're stuck with aldehyde, we're stuck with C2H5. That's our problem, right? It's not that we don't want to do aldehyde, but we cannot. So let's do alcohol. Let's do alcohol and put the alcohol in the appropriate place where it will, cut off the C. This makes more sense, right? Then we don't have to use aldehyde or ketone also. I think it makes more sense.
Okay, alcohol.
Right. Austin, you should be done, right? I mean,
yeah,
it's just like that. Huh? I don't think this will repeat itself. I will be surprised if this comes out in exam. I'll be surprised. It just comes up as a weird question. Now, what do you want to do after this question?
I'll do some physics because I didn't have time yesterday.
Sure thing. Again, YanKeen, you have to have 2C in the alcohol side chain because if not, you're stuck with 2H5 again, right? Right. You still have to have 2C. You still have to. I think that's what they are giving us hint or something, whatever. So it's a matter of putting the alcohol on the first C or the second C lah. I think that's the decision making here lah. And I think I know where you should put it. Yeah, I think I know where you should put it lah. Because the alcohol will determine how the carboxylic acid is formed. So it's quite clear where it should be lah, right? It's quite clear.
You build the first one, right?
Yep. If the second one, then it will be that as a carboxylic end, which is not what you want, right? So I think we are basically done with N as long as the H fits. Does the H number fit?
I go toilet.
1, 2, 3,
Yes,
4, 5, 6, 7, 8, 9, 10, 11, 12.
11?
Yep.
12. Oh, it's 12. Yeah.
H, no H.
Yeah. So let's say we don't know what M is. Like I said, we don't know. We still can skip that. Okay, we're still quite proud. We can have L and N, and then we can still try to do B lah. We can still try to do B, which is not bad.
Okay.
Right, that's right. Okay.
So N is alkaline equals iodine. That was the triiodomethane test.
Triidomethane thingy, yeah. And is there a oh, there are two methyl ends, right? There are two methyl ends to triiodomethane lah, right? There are two. Yeah, that'll work. I think that'll work. The two methyl end will. Hey, wait a minute.
Okay, wait, a bit.
No, only the first one. The other side chain will not, because the methyl end must be connected to a C with alcohol.
OH.
Yeah.
So it'll only be this one.
Yeah.
Right. Okay.
Yeah.
I need to write this down. How do I? Okay. Let me see.
Mm-hmm.
I need to take out the carbon, which is from, oh boy. Right. Balance equation. So it's
No. The phrasing of the question is write a balance equation, which is to say you can write the shorthand, right? You don't have to write the structural formula, right? I think the easiest way to do it is just to take out the CH3 at the end. So you basically write down the N as C9H12O. You don't need to write down the structure. It's just C9H12O. A very short way of doing it. I think it's fine. And then you plus your stuff, right? Whatever that stuff is. And then at the right hand side, you have your CH3I, right? Basically, right?
I need this space for a number, right?
Mm-hmm.
CH3I.
Yeah, you have your CH3I, and then obviously
CHI3.
Sorry, CHI3. Yes, what am I talking about? It's triiodomethane. And then that is because one of the thing is the CH3 is being cut off basically, and then you're left with something minus the CH3 but plus something else lah. Oh no. It's just that thing, that whole thing with a minus lah. It's just that whole thing with a minus lah.
It's just like in this entire
thing, right? This is alkaline, right? This is alkaline, so it should be a carboxylic, right? It should be a carboxylic. Yes. So that entire thing plus one O and then a minus, right? And then a minus sign.
This whole thing plus the O and the minus.
Plus another O, right? So you have two O now. You have two O and then a minus. Right? And then you balance that, that's enough. So it'll be C8, right? You're thinking too hard. It must be C8, and then it must be H12 minus 3, right? 9, and then but O2 lah. O2, and then with a minus. Yeah. If this makes sense to you.
After some time.
Right. And then you balance this, I suppose.
Yeah, you balance it.
Yeah.
Yeah.
Okay, let's see what happens. Right.
Okay.
Yes, Austin. Right. Oh, so I'm saying electric field. Yeah. Okay. All right. Feel free to ask me questions. Oh, yeah, very fast. Oh, yes. Oh, wow, so short. Such a short note. Okay, good. Is your question number 1?
I haven't started yet.
Right. Are you sure you run out of questions already?
Not yet, but I think cause this is like more urgent, I guess.
Feel free.
Actually, Actually, never mind. I got chemistry question.
Sure thing. I think answering the question which are there, I think will save you more time. Or other progress. I don't know, whatever. Let's give it a try. Zoom in, please, though.
3 there, right? So
Finally, a K question. Because that. Yeah, okay. So 3 unknown solution A, B, C. Okay, I'm just going to copy this one. Very nice connection. I like it. Okay, so what is your question, Austin, actually?
I don't know how to answer this question.
All right. So yeah, monobasic, weak monobasic, and that's nice, right? So all mono stuff I like. Mono stuff are easy. So
I'm supposed to find the PK.
sorry.
Oh,
Not necessarily saying what is sure thing. Yeah, sure. So he tells us the P. Oh, right. It's wait.
I'll put the last 10 question there. Then you can go to math.
Sure thing. Please wait. I'm going to Austin.
Yes.
So pH 2.4 and pH 3 are considered very strong acid, right? Very strong acid. Well, no. Wait. Before I say that, okay. So pH 3 can still say that's the borderline weak, wait, no, that's pH 5. But it's not strong. That's the problem. Think for one. Okay, right. So let's talk about C first, right? So C, the concentration of the H plus is equal to the concentration of the solution, right?
Yeah.
Basically, right? So we are saying something like this. So this is clearly an indication of a strong acid. Clear. Not A though, but C is. Because if your whatever, I'm just going to write down, right? It is a HA, again, mono basic, right? Mono basic. Becomes H plus A minus, like 100%. That's what strong means, kind of, right? So 0.001 here will be 0.001 here and 0.001 here. So clearly this is strong. Done, clearly, right?
Oh, yeah.
So C is strong, confirm. And A is therefore not strong. It's acidic, but it's strong. Clear already.
Huh?
A is clearly not strong because you are given 1, right? This is a solution.
Oh,
C, right?
and very
and
little.
you only have, much smaller, like that's actually less than 1%, less than 1%, less than 0.2%. So A definitely contain a weak acid in the sense that I don't think it'll contain a strong acid, and I don't think the base have anything to do here.
So 1 is a weak base. B is a weak base, right?
B is a, let me think first.
Wait.
No,
it's a strong base.
No. Because you have to go to, you have to, because concentration of H plus means you know the concentration of OH minus, right?
Really? I forgot how to find.
Hey, wait. Do they tell you something like this? If pH plus POH is 14, right? So this case, this is 12, so this is 2 lah. Then the concentration of OH minus is 0.01, and which is exactly the same. So it's a strong base. Right? You have the POH, you have the POH, and B is clearly strong. So you just have to think about part 3 lah. Because part 3 is a weak acid and strong acid. Maybe.
So, it should have buffer, because buffer is weak. No, but there's
the issue is 50-50. The issue is the 50-50 thing. Just confirm, because the concentration is different, just confirm that will be okay, right? You have one, you see, you have option 1, 2, or 1, 2, 3. You see, you still have to think about 3. You still have to think about 3. Think about it for a while.
Wait, no.
Think about the concentration of A. I think that's what you want to worry about, right? I think. Will they? Because we don't even know what's the weak S. I don't think it will be. No, I don't think it will work at all. Yeah, I don't think it'll work at all. You think about it. I don't think it'll work.
Because the concentration of A is higher.
Again, wait. I have to be clear first. I'll call this HC. Okay, easier lah. HC, right? HC, and let's call this HA. Right?
Wait, Kak. Is it? Can I say like this? So since C, it seems
Yes.
that C will be the limiting, right? Which means that A will be in excess.
A will be in.
So weak acid and salt means it's a buffer.
No. My issue is this. Look. In terms of buffer, you're supposed to add this, right? Correct or not? This is the weak acid, and you're supposed to add this guy, right? Am I correct? This guy. Correct or not?
Really?
Oh dear. Let's go to your buffer node again. This is the first page of making buffer. Right? I want you to understand. The first page of making buffer. First page. Maybe first or second. Right. While you open the node, I'm going to go to YanKeen first. So YanKeen, what is? I don't get the questions, right? Oh, you put it somewhere. I'm sorry, you put it somewhere. Right. Page 3. Yeah. So just a minute. I'm going to point something to Austin. Wait, buffer. Yeah. There, a large buffer. What is it? Yeah. See. So CH3COA is a weak acid, right? So you will expect the H plus, the H3O is to be small in amount, and the CH3COO to also be a small amount, correct? That's what you expect. However, you go and add CH3COO-Na to give a large amount of CH3COO minus, correct?
Yeah.
Right? So you need the CH3COO minus in large amount, and then you dump it into the weak acid. In short, you need the A minus. You need a lot of A minus from somewhere else. Correct? This guy cannot provide you with A minus one. It's a totally different acid one. Right? It's something else lah. It's, I don't know. It's HC. He's going to provide you with C minus, not A minus. So you cannot make a buffer out of, mixing this with that, because what you need is more A minus, not more C minus.
So it must be related.
Not just related, it must be exactly the same. Like you have to CH3COO minus, you need that. That's what it means to make a buffer. So no way, they cannot be the same acid. How can a same acid be, strong and weak at the same time? Cannot be. Right? So I don't think part 3 is correct. I don't think
so. It's B.
I think it's B. Right? I'll go to YanKeen first. Sorry,
Okay.
YanKeen. So I'm reading from your question. Yeah, nice. You're talking about part B, right? And then draw the structure of the problem when the above compound is subjected to the following region. Okay, right. So is the compound what you put in the Jamboard? This big thing?
Yeah, that's what.
Okay, then you're reacting it with potassium carbonate. That's a very weird.
Like I know that one gives me a COH, right? When
sorry, I don't get what's sorry, K. Yeah, K. Why do we want a what? Why do we want a what? Why do we want a potassium carbonate? Wait, what? Sorry, this is X-alkene. This is alcohol, right?
I was working off the information of this one, which I didn't find in my notes anywhere. So, that's that.
Yeah, but the potassium carbonate will not do anything. What?
Yeah, that's what I thought, but it can't just be nothing, right?
No, it can be. No, it can. Who say it cannot?
I mean, I don't know.
In O level, although you don't realize it, but they teach you a lot of reaction that doesn't happen. This is not supposed to happen. It's just they never put it that way. They never put it that way.
Okay.
I'm really thinking that nothing will happen. This is a salt, right? A potassium carbonate is a salt. It's a soluble salt because of the K plus, but K plus is never known to react with anything, right? K plus doesn't matter. CO3 2 minus may, what does CO3 2 minus do? Well, if it meets an acid, then it will do the, then you have a insoluble white thingy, right? If he meets an acid, that's the only thing that will react with a carbonate, or he meets another salt. You cannot oxidize it. Again, correct me if I'm wrong, YanKeen. In the thing, I see a lot of alcohol. Here's alcohol, right? And then there's alkene, and then there is a halogenoalkane. That's about it, right? That's about it, right?
Pretty sure, yeah.
If you look at the summary page, alcohol, alkene, and halogenoalkane, none of them react with carbonates, right?
I don't think so.
I don't think so too.
I was working off this information, but that's only for COOH, which isn't.
Yeah, acid, man. Again, carbonate meet acid, okay lah. Then it'll give you CO2 lah, okay lah. Everybody agree with that. That's just O level stuff lah. There is no acid here, what? There isn't, right? I don't see any COOH. Yeah, there isn't one. Yeah, there isn't one.
So I just put no. I just put the same thing.
Yeah, no observation and no reaction is my first guess lah. I don't think I can guess another thing. Alcohol are acid, but super weak acid doesn't count. It doesn't count. It really doesn't count. The note even states that it is too weak to react with carbonates. Your note states that, remember? When they talk about the acidity of alcohol, he puts that disclaimer. So not gonna happen.
Okay.
Yeah, Yeah, the Cl minus detaching does not help in any way at all. The halogenoalkane Cl minus detaching does not mean that it will be replaced with CO3 2 minus. I don't think so. Yeah, because that cannot happen. That doesn't work. KCl, no, I don't think anything happens. I don't think. I might be wrong, but I don't think so. Yes, Austin, next question, please.
Yeah, this one.
Which one? Number 3. Okay, please zoom in. And yeah, very nice. So I'm just going to copy that first. Which one of the following acid solution can be used a buffer? Yeah, nice. By partial neutralization. Wait, so first of all, he wants partial neutralization. So D is gone because it's not acidic. C is gone.
It can't be acidic.
Because if he talks about, first of all, he already tells you that it'll be acidic solution. NH3 cannot be acidic. Well, but not with NaOH. I mean, just put it that way. It cannot be acidic with NaOH. They are both, it can. So D is gone. I don't think H2S can also do that. I don't think so. So I'm just considering A and B. I'm just considering A and B. So both are weak acids. So I guess that's good, right? That's good.
I don't understand why H2S and NH3 cannot. As in NH3 okay, but why H2S cannot?
What is H2S? Let me think forward. Again, let me think forward. What is H2S? H2S is not an acid, right? Okay.
Sulfide.
Yeah, I'm going to check that hydrogen sulfide is not acid. I'm just going to confirm this. So yeah, forgive me. I'm not a university level chemist, so is acidic. So I'm just going to check. H2S, is it acidic or not? He tells me that hydrogen sulfide is a gaseous acid with a pKa about 7. It's 7. Hello. Okay. H2S is a weak acid. Acidic gas. H2S is a acidic gas. H2S is more acidic than H2O. That doesn't help, okay? That doesn't help. Anything is different. I have no idea, okay? Currently, I have no idea. I'm just going to look at A and B first. I have no idea about H2S, right? I'm not sure at all. Huh? I'm not sure at all. Maybe I'm wrong. Maybe I'm wrong. Huh? But I'm going to look at part 1 and then part 2, part A and part 2. So again, he wants an effective buffer solution. So you have to start with a weak guy. Now, the partial neutralization, you are wrong to think that it is reversible. It is not reversible. It is irreversible. Austin, the reaction that you're writing is wrong in terms of irreversibility. It should be irreversible. Neutralization is reversible. Now, this is good news because then you have quite a lot of CH3COO minus. You know what I'm saying? You have.
Yeah.
Okay. Now let's write down the weak acid reaction, the CH3COH. You know, reversible into its weak component. Right. Let's just write it down. YanKeen, again, please show me your question.
Oh wait, I remember my teacher taught me, right? Wait, sorry. So this is the salt, right?
Yeah.
So this salt
will contribute. Yeah, it will ionize because Y is Na plus. So that is contributing to the weak acid thingy. This is what you need for. This is what you need.
So whether it produces H3O plus or OH minus is what contributes to acidity of the buffer.
What did you say? Sorry, the last sentence. Sorry, what is it?
Like, how do you say? Like it dissociates into its.
It's CH3CO minus. Yeah, we need the CH3CO minus, right?
Like whether it like produces OH minus or H plus will determine whether the buffer is acidic or not.
Yeah, but acidic or basic buffer works the same. They both buffer both ways. Do you understand this? Buffer, whether acidic or, I mean, yeah, buffer can be acidic, buffer can be basic.
This one.
But a buffer will buffer both ways.
Oh, my teacher wrote it here. Then.
Yeah, but do we need it for this question? Sorry, what you're saying is correct, but do we need it for this question?
Yeah, because it says pH below 7.
Ah, right. I mean, both are acidic already. What? A and B are acidic, so should be okay, right? Sorry, why is this? I don't get it. Why is this a concern? By the way, your first reaction should be H2O. By the way, it's neutralization.
Oh, why is it not NaOH?
No, NaOH, right? No, shift to the left, please. I cannot see. Shift to the left. Yeah, the right hand side is not OH minus. What are you talking about? Is OH minus meeting H plus H2O neutralization, no?
Oops.
Right? Don't make that mistake though. Maybe that's why you're confused. Maybe I don't know. Maybe. Right? And this CH3COO minus Na plus, you just need the CH3COO minus. They will automatically dissociate anyway. So you have the CH3CO minus to contribute to the weak reaction. No? So what's the weak reaction? Which is what you have just written. Basically what you have just written. No? Yeah, what you are writing.
So this is above 7, so it's not this one.
This is not how it works. No, let me think more. Yeah, this is not how it works. How you understand it is no, this is not how it works. This is not how it works at all. Let me just write something. Oh my goodness, this is so important. I'm sorry. I cannot say that you have to understand. So cannot. I'm gonna copy this. Sorry, YanKeen, don't wait for me, YanKeen. Please don't wait for me. Do something.
Yeah.
Do something.
I had a PnC question, but it was all those part 3 questions where it's like all the weird conditions.
Yeah, you should. Why are you still at question? Never mind. No. Sorry. Don't wait for me first. Don't wait.
I've done this already, but I didn't know how to do.
I know. Do something else first, please. Sorry, do something else first, please. Just a minute. I'm not saying that this is wrong. This is something correct, but look. This one is the first thing, right? And then there is always the second thing. The second thing is not this. The second thing, first thing first is you have remaining, right? You still have remaining CH3COH, right? You still have, correct? Because partial, huh? So then what kind of reversible reaction does the remaining thing have? Just the normal K reaction, the normal reversible reaction of CH3COH being a weak acid.
I don't remember.
Well, you don't have to remember anything. It's a weak
Plus
acid
H2O.
dissociation. Okay, yeah, it's a weak acid dissociation, right?
Yeah, plus
So,
H2O.
okay, fine, plus H2O. And then what?
CH3COO minus plus H3O plus.
Yeah, well, which is H3O plus, which is a H plus, basically, right?
Yeah.
So first and then second. First and then second. Right? Now let's talk about this guy. First of all, you're concerned with this guy, right?
Yeah.
This guy, instead of doing things by his own, we should be joining this, should be included in this system, because this is already happening, instead of doing his own thing. Okay? So you remember this is originally small amount, right? Because like this is 99%, this is 1%, right? A small amount, right? And then suddenly you add a large amount. Like this is a lot, because this is a full reaction. When you add this as a large amount, everything will shift to the, therefore you have a shifting to the where, like or left? I'm not making any sense. Sorry.
Wait, what?
Again, reversible reaction, right? Reversible reaction, 99%, 1%, 1%, weak acid. Make sense? Testing, can you hear me? Oh, we are lagging. Hello, we are lagging. Hello,
yeah,
we are probably lagging. Hello, can you hear me?
Yeah, I can hear.
Okay, again, 99%, 1%, 1% reversible reaction, correct? And then adding a large amount of this guy, dumping it here, correct?
Yeah.
We're adding a lot of this. So reversible reaction, things will shift if you add something, right? Things will
shift to left.
You'll shift to the left, right? So that simply means reducing the availability of H plus, reducing H plus, because we are shifting to the left.
Yeah.
But you cannot reduce until 0, right? That's also something you learn. So there'll still be some H pluses. So my thing is, first thing first, you will reduce the H plus, so it'll be a very small acidic buffer. Second thing, this does not happen, because you should be considering this. This does not happen. You should be considering this instead. Let me put it another way. If you're considering this, you still have to consider the interaction between OH minus and the H plus here, which is very complicated. You don't know how to do that. Rather than doing this, just dump it here and then conclude, I will still have some H plus, although it is very small. So it is still very weakly acidic. Still very weakly acidic.
Yeah.
Right. I think that's a better conclusion. If you do it this way, then you conclude it's basic. I do think that's the correct conclusion. I don't think that's the correct conclusion.
Yeah, I think so.
Right. So that's A, that's A, right? Wow, B is very weak. This B is even weaker.
But both are below 7.
Correct. I'm currently very confused about HI. Maybe I'm missing something. Am I missing something? The NAI, no. The NAI is fine. I'm going to think about this. Part B, I'm not so sure. Although my answer is probably A, but I'm not sure about part B. I'm going to have to check it out, right? Any other question?
No.
All right. Then it's 5:30, is it? No, it's 7:30, right? For you, let's end here. I would like to answer YanKeen one last time.
Okay, okay.
Okay. See you
Bye-bye.
on Tuesday. Bye.
Tuesday. Bye-bye.
Austin, come YanKeen. Sorry.
5.
5. Okay, we are still lagging. Okay, very nice. Right. So, is your question 1, 2, 3, or 4?
Part 4. 5 part 4.
Can we not talk about part 4? I'm serious. Do you is there really no other question but part 4?
There's 6 as well.
All right, let's talk about 6 first. At least 6 is not just part 4. Okay. Okay.
Yeah.
So, what is your question about part 6?
Just question 6.
Sorry, shift to the left. Sorry, shift to the left. Shift. Nice. Yeah. Okay. Okay. Keep it there. Right.
Sorry.
Okay. Thank you. So again, ask me your question.
So I created this source structure, which is very complicated.
Looks complicated. Yep.
Yeah. So the question said that the green has to be together, right? So
yeah.
Please zoom in a bit. I said the green has to be either like that or like that. Like all the positions are, so I calculated 7.
Okay, let's go like this. Okay, let's go quick. Yeah, let's go quick. Yeah, because we're at time. Right? Usually we will discuss longer, because but now. So you are now. This thing means it's a super group, so I think what you're doing is that it becomes a super group, right? So super group first, a super group of 4, which should be treated as one thing because they are always together, right? Done. You super group them, right? And then the red books are always separated, and then you have 4 distinct blue books, right? Let's settle the always separated. Let's settle the always separated. Oh,
yeah.
I will settle it this way. I will settle it this way. I will settle it in a way that I will group the red book together. This is reducing the complexity. So I'm doing the exact reverse, you see. So this is green, yeah? Green. I am considering the red book to be together. L1, R2. And then the blue book can do whatever they want.
Yeah.
Right? I'm going to calculate that. And then I'm going to
minus away from
again, this is always together. This one I'm going to minus away from the red can do whatever they want. No, the gray is always together.
Green is always together.
Yeah, I'm going to minus that from the red can do whatever he wants, whether together or separate. That's easy, right? So red can do it. Then I will simplify my problem. 1 minus that.
So, but green together, I was thinking green can be together anywhere, right? So we need to take into account the positive.
Sorry, you're saying green can be together anywhere?
Green can be together anywhere in the shell.
Yeah, correct. So right now, for the purpose of anything red, red can do anything, right? So red can do anything. Then we have 7 slots, right? 1 big slot for together, and then you have 6 more slots for red and blue to do their stuff. You have 7 slots. Make sense? Then do whatever you want with the red and the blue. The red together, right? That's what we're doing. The red together, you will have 1 big green, right? Yeah, 1 big green. 2, 3, 4. And then I have another slot, which is red together. And then I have 4 more slots for a total of 6 slots. Blue 1, blue 2, blue 3, blue 4. Correct. Sorry, am I making any sense, or do I have to go in more detail?
It makes sense for now, yeah.
Right. So this is what you try. Look, this minus that. Now let me say something about the super group. The super group, even though they're together, you still have to consider that inside the group they can shift and they can shift.
But would that make any difference?
Yes. Because even though they are together, again, reading from the question, I think, in the same order. Wait, they say in the same order. Then it doesn't matter. You cannot alter the order.
Yeah.
Sorry. That means this is like the green is there to confuse us. The green doesn't matter. The green is just 1 big lump of green. It will never change.
Yeah, that's what I thought. But
the red, however, can do that. The red in the group, because we're doing R together, right? So remember, you can do R1, R2, or you can do R2, R1. And R1, R2 is different from R2, R1, even though they are together.
because it's distinct.
Yes, because it's a distinct book, and arranging on a cell, we interpret arranging on a cell as the order does matter. For example, if I put green 1, 2, 3, 4, R1, R2, that's slightly different from green 1, 2, 3, 4, R2, R1, something like that.
Oh, great.
Right. So there's a ×2 factor here. Even though they are a super group, a big like a super slot, still you ×2 to account for it.
All right.
Right. So again, for R together, do 6 slots. For R anything, do 7 slots, and you will be happy if you -2. Okay.
I'll certainly give it a try.
Yes. Any other question on PnC? Just curious.
I have more because
Show me a bit. Just show me a bit. We don't have time, but show me a bit. I want to see your types of questions.
like seriously there are a lot. Some of the big ones.
There should be a lot, but yeah. I mean,
at least five are used. I'm not sure what.
Yeah, I would. Yeah, if I have time, I want to talk about that. So that's good. Anything else?
The people in a row. Some of them are just like throw it away. But math is not due Tuesday, so I was gonna do this tomorrow.
Okay. So understand a few things. For PnC, your tutorial will matter a lot. Meaning to say, you're gonna bring in a lot of questions into the tutorial. Totally.
Great.
Totally fine. It's totally fine. You will be very aware of what they're trying to explain to you. That's not great in a negative sense. Please, your habit of thinking haven't changed. You go in tutorial with a lot of questions. That's great. You don't go out of the tutorial with a lot of questions. That's not great. You have a very high chance of going out from the tutorial with a lot of answers because you know your question. Okay, have that mindset, please. Have that mindset. I'm serious. If not, then why do you attend tutorial? I've done everything. Then don't do tutorial, right? Good job. Really, no?
All right.
Good job. Good job.
Okay.
I wish I can answer more, but okay, give it a try tomorrow, and I'll see you on Tuesday. All right.
I'll definitely ask you out because I don't think math is. I don't think the tutorial lesson on Tuesday is gonna wrap up the questions.
Now, how good are we in catching up at this point? Everything.
Pretty okay. Math should be fine. I think physics the only big gripe because I'm
I feel physics a bit. Yeah, I feel. But chemistry is okay.
I'm okay with the post-lit, but I feel like I won't be okay after I learn diffraction.
No, you won't. No, you won't. I want you to spend more time with physics, considering that your chemistry and your math is going to benefit from the tutorial. Right? Right now, your physics might not even benefit from the tutorial. That's bad. Right? You see how we study, right? We just want to benefit from tutorial. You are ready to benefit for chemistry and math. So we can say we are catching up, and we will probably be able to keep up first week because there will be more new things.
Oh yeah, definitely. Physics.
I would argue that you don't have to concentrate too much about math if the option is between math and physics. You may want to try physics first. Math, just leave it to the tutorial class. That's fine. Yeah. Everybody have questions on PnC. Everybody, even the smartest guy. Okay, it's a weird thing. Okay, it's a weird topic. It's a new topic. Okay.
All right.
Okay, be kind to yourself. Okay, see you on Tuesday. Physics. Bye.
Bye.